Okay, this is a class on limits and continuity. Limits and continuity are one of the most basic topics of calculus, and it's natural that we begin the study of calculus from these topics. To illustrate the concept of limit, we'll begin with an example. We take any function y defined as x square. Now we take some point x0 is equal to 2. Now take the values of x which progressively become closer to 2 and calculate the corresponding values of y is equal to x square and tabulate them in a table. So for first we see the values of x which are smaller than 2. This is 1.6, 1.9, 1.95, 1.999, and likewise any number of values of x which are more and more closer to 2, and we find the corresponding values of y is equal to x square here. So, and we tabulate these values likewise for higher values of 2, and we find the values decreasing and approaching towards 2 and tabulate the values. So if we see that the value of x as it approaches 2, the value of y, if it approaches a fixed number, in this case 4, we say that the limit exists on 2 as the values of x approach to through smaller values of 2. That is, if it's a number line, this is x is equal to 2, we say that the limit exists on 2 if x approaches 2 through smaller values on 2, then the limit here exists. This limit is called left hand limit because it's approaching from this side. Again, if this limit here, this limit also exists, that is the limit approaching 2 from values higher than 2, then we say that the limit exists. This limit is called right hand limit. So limit at a, so this was a case of a function. Now suppose there is any general function y is equal to f of x, and instead of 2 we take some value x0, and to find and to see that the limit of function y at x0 means that there are two limits. The left hand limit, which is denoted by x tends to x0 with a, this sign is used for of f of x. So this is called left hand limit. Left hand. Likewise, limit of f of x as x tends to x0 plus, this is called right hand limit, that is, which implies that the values of x approaches x0 through values greater than x0, which is in this case this is the example. So the definition that we say that the limit exists if the limit on the left and the limit on the right exists and they are equal. Alright. Okay, so we'll give a graphical interpretation of a case in which limit might not exist. For example, suppose a function y is equal to fx is defined in such a way that its graph comes out like the graph shown here. This region, this part, and this part. So if we take any point x0 dash which is not equal to x0, see that the limit exists on the left and from the right, and it approaches a value this here, and they are equal. So for any point which is not x0 dash, there will the limit exist. But for x0 dash, the left hand limit is this value and the right hand limit is this value, which are obviously different. So left hand limit and right hand limit are different, and so the limit is said to does not exist. Though individually left and right hand limit exist, they are not equal, so the limit does not exist as per definition. Okay, so this is in this we'll see how to find limits of a function. Suppose there are two functions, f of x and phi of x, and for limit x tending to x naught, limit of f of x is say f naught and phi of x is phi naught. So the general rules of algebra apply, that the limit of f of x plus phi of x as x tends to x naught is equal to f naught plus phi naught. Likewise, rules of multiplication and division apply, like the limit of f of x divided by phi of x is f naught by phi naught, provided of course that phi naught is not 0. Okay, let us take an example. Suppose there is a function x square plus 3x minus 2 divided by x cube minus x square plus 4, and we are required to find its limit as x tends to 2. So what we have said, that if the limit of the numerator exists and the limit of the denominator exists, then the limit of this function as a whole will be the limit of numerator by limit of denominator. So the limit of the numerator, in this case we put x is equal to 2, this will be 4 plus 6 minus 2 is equal to 8. Likewise, in the denominator we put x is equal to 2, this will be also equal to 8. So the required limit that we want will be numerator by denominator, 8 by 8, which is equal to 1. So in this case the limit of this function is equal to 1. So let us take another example. Suppose we have the function x square plus 3x minus 2 by 2x square plus 3, and we have to find the limit in the case where x tends to an infinite value. So when we say x tends to infinite value, it means basically that x tends to very large value, that larger than any other number we can imagine. So to solve this kind of problems, what we normally intend to do when x tends to infinity is to bring this number x in the denominator. So like this is the approach we do. We divide both the numerator and denominator by x square. So we'll get this function 1 plus 3 by x minus 2 by x square divided by 2 plus 3 by x square. So when, because x is a very large value, terms like this term and this term tends to 0, because when we divide by a very large number it tends to 0. So when x tending to infinity, this value will become equal to half. This is in this way, in this case the limit will be half. Okay, so let us take a little different example in which we have to find the limit of x tends to 2 of a function x cube minus 8 by x square minus 4. So in this we simply cannot put x is equal to 2, because the function as such is not defined at x is equal to 2, because x square minus 4 that is equal to 0, which makes the function undefined for x is equal to 2. So in this kind of problems we try to factorize and to see if there is a common factor which gets cancelled. So in this case it's obvious that we can factorize x cube minus 8 and x square minus 4 like this. X cube minus 8 can be factorized as x cube minus 8 can be written as x cube minus 2 cube, which is equal to x minus 2 into x square plus 4 plus 2x. A cube minus b cube is a minus b plus a square plus b square plus ab. Likewise, x square minus 4 is equal to x minus 2 into x plus 2. So now the given function, this becomes equal to x minus 2 on the cancels, which becomes x square plus 4 plus 2x by x plus 2. Now in this function we can put x is equal to 2. This will become 4 plus 4 plus 4 by 4, which is equal to 12 by 4 is equal to 3. So the limit in this case is equal to 3.